Welcome to the IDEX Fire Safety Group S-Key Service and Troubleshooting Guide Part 2. In Part 1 is an overview of the Class 1 S-Key electrical system. In Part 2 we will cover network operation, S-Key Pro 2 software and system troubleshooting. Visit the website www.firmware.class1.com for read-only S-Key Pro 2 software, VDR software, drivers and firmware for all Class 1 products. Anyone can gain access to this website. Visit the website at www.akronbrass.com for information on the S-Key system components. Click on the Vehicle Electronics tab. This will open a box where you can see all the Weldon and Class 1 links. Click on any of the links that's listed under the Class 1 logo. The S-Key Pro 2 software is a desktop or laptop application for the custom configuration of the electrical systems of emergency and industrial vehicles. The target vehicles are designed and built around a CAN bus network containing a variable number of S-Key modules that, to simplify, control inputs, e.g., switches, and outputs, e.g., lights. At the core of each vehicle network is a Universal System Manager or supernode that implements the configuration created using this software. A modem, a serial, a USB interface module or a USB cable can be used to load new configurations, diagnose and monitor system activity. The S-Key software is intended to provide a user-friendly interface to a very complex onboard control computer. The S-Key Pro 2 software is used designing, uploading or downloading the database, monitoring and diagnostics. With it, you can verify communication to all nodes, monitor network messages, send messages, check for system faults, and download input and output information from the node. There are two editor sections in the S-Key Pro 2 software, a network editor and a device editor. Both editor sections can perform diagnostics. The network editor serves as the high-level design tool for a vehicle network, providing a view of all the devices on a network and their associated ports. The network editor is started when the user opens an existing project file or creates a new project using the toolbar or file menu, and is the primary window displayed in the application. The device editor is used to create and configure ports for devices created in the network editor as well as to configure certain features for special purpose devices. Each port can be configured. This includes naming, load manager settings, polarity selection, special program ports, such as seat belt and vehicle data recording configuration and multiplexing for all output ports. The connection type field allows the user to choose a serial, a modem or a USB connection. Each time the user changes between serial, modem and USB, the system is scanned for available ports of the given type. If a COM port or modem is currently in use by another application, it will not appear as a selection for configuration. If the intention is to use an external modem, ensure that it is powered on and connected to the PC before selecting modem or it will not appear as a selection. If a USB is used, the port will be found automatically after selecting the USB connection type. Selecting the network menu, then click on Connect or click the Connect icon on the toolbar. This will start the connection process to an S-Key system via configured serial port, modem or USB. The S-Key system allows for the database to be uploaded to or downloaded from the Universal System Manager. Diagnostics can be accomplished in the Network Editor page or Device Editor page. The system faults can be downloaded from the Reports menu and then select the type of report needed. Diagnostics can be locally or remotely using S-Key Live. Text explaining a button's function will appear when you hover over it. The S-Key system has several ways to communicate with the CAN networks. The first is USB extension cable A to A male part number 629 to 00025 for Supernode USB. The second is USB to 12 position Deutsch connector part number 513 to 00011 USM2, and the third USB to CAN adapter part number 115772 for all S-Key CAN networks. This allows customers to connect their Windows-based computer to the S-Key network for either node downloading, uploading, update firmware or network troubleshooting. Please check for the latest versions of these modules at www.firmware.class1.com website. Updating the supernode, Universal System Manager or Vehicle Data Recorder is dragging and dropping the firmware file onto the module drive using Windows Explorer. From the network editor, click the Connect toolbar icon or select the network, then the Connect menu entry to connect to the vehicle. Successful connection is indicated by several things. The Connect toolbar icon will look like as if it pressed, the status bar shows connected, yes, and the remote status bar becomes populated with the information for the configuration that is stored on the vehicle. If the connection fails, a dialog box will pop up indicating failure. Verify the connection type selected in the system menu, then select the connection selection. Verify the system is powered and all connections are properly connected. Note that most of the features in the system that require network connection will automatically connect if not already connected, hence explicitly connecting as described here is rarely necessary. To make changes or troubleshoot a configuration that is already installed on a vehicle, the configuration file must be downloaded to the PC running SKey Professional. Once connected to the system, you can download the configuration or database file from the USM or SuperNode. Click on Network, Flex Transfer or Synchronize, and then select Download All if it's a Flex file or Download to PC if it's a card file. The Flex Transfer menu entry allows you to upload or download the configuration on a vehicle network. The Flex file contains the current configuration, system display, data logger, special features and switch types. You may also download the current configuration from the USM or SuperNode to the PC for updating configuration or troubleshooting using SKey Professional. The Synchronize menu entry allows you to upload or download the configuration on a vehicle network. The Synchronize contains only the current database. The system display, data logger, special features and switch types will need to be uploaded separately. You may also download the current configuration from the USM or SuperNode to the PC for updating configuration or troubleshooting using SKey Professional. Once the configuration is downloaded, the system modules will be displayed in the network editor. The network view is represented using a standard Windows tree view interface that provides a familiar interface with infinite extensibility. Users may browse any device in the network displaying all its configured inputs and outputs. Adding new devices to the network is accomplished using the Add Device toolbar icon, or selecting Add Device. From the Network Editor pop-up menu, right-click to select the device type to be added. The Network Editor can also perform diagnostics with the viewing of the status of inputs or outputs, and forcing on or off the desired input or output. The Device Editor discussed in the next section handles configuration of the device specifics, and can be accessed by double-clicking left on a device or any of its configured ports. Deleting an existing device using the toolbar button will remove it from the network, and remove its ports from any configured multiplex operations. An appropriate warning will prevent the user from deleting devices accidentally. To access the Device Editor screen, double-click left anywhere on the Network Editor screen. The Device Editor tree view provides a graphic view of the network devices and their associated ports and vocation interlocks. As a port or device is selected in the tree view, the controls and tabs displayed on the right side of the screen are enabled or disabled and populated based on the type of object that has been selected and its capabilities. The selected item is always highlighted in red. The Settings tab is a context-sensitive tab that is divided into four main areas for device, port name, port default state and output-specific configuration. Depending on the type of object selected in the network tree view, the appropriate areas will be enabled to allow configuration of the component. The Network and Settings tab will provide information related to wire size, circuit name, wire number and polarity. The Multiplex tab is the most powerful piece of the SKey Professional application, allowing the user to configure or diagnose the logic that controls any given output on the vehicle. There's an upper and lower section to the Multiplex window. The upper creates the logic statement using operands, and, or, and not. The lower section is an aid to understanding and troubleshooting multiplex logic. The logic for the multiplex equation created in the multiplex editor is written out in text form in the circuit logic window below the editor. This window is updated any time a change is made to the equation. Select the port whose multiplexing needs troubleshooting. Click on the real-time network monitor to view the state of the port. Evaluate the logic states to see which port is not functioning properly. To verify a circuit, you can force on or off the input or output. When forcing on or off inputs or outputs, be careful not to cause bodily injury to anyone near the vehicle. The Settings tab is a context-sensitive tab that is divided into four main areas for device, port name, log activity, input polarity, port default state, and output load settings. Depending on the type of object selected in the network tree view, the appropriate areas will be enabled to allow configuration of the component. The Network and Settings tab will provide information related to wire size, circuit name, wire number and polarity. The Quick Edit tab in the upper left will allow for configuring all input and output settings. Multiplexing of system outputs is the single most important part of the SKey system, providing the user with a flexible, configurable network that supports complex circuit logic without the complex wiring. Editing the multiplexing for a system output creates a logical equation consisting of operands, operations, and, or, not, that when evaluated provide a result of true or false. Multiplex equations that evaluate to true cause the associated output to turn on, false results turn the output off. Equations for every output in the system are evaluated by the USM or supernode any time there is a state change on the network, and output states are changed based on the results of the equations. The AND operand will be blue in color in the shape of a square with two cut corners, a flat back and a dot in the center. If a logical AND is used, all ports will be ANDed, meaning that all of them must evaluate to true for this sub-operation to evaluate to true. The schematic shown represents the multiplex expression and circuit logic. The circuit logic is an aid to understanding and troubleshooting multiplex logic. The logic for the multiplex equation created in the multiplex editor is written out in text form in the circuit logic window below the editor. This window is updated any time a change is made to the equation. The OR operand will be green in color in the shape of a square with two rounded corners, a curved back and a plus sign in the center. If a logical OR is used, all ports will be ORed, meaning if any one of them is true, then this sub-operation evaluates to true. The schematic shown represents the multiplex expression and circuit logic. The circuit logic is an aid to understanding and troubleshooting multiplex logic. The logic for the multiplex equation created in the multiplex editor is written out in text form in the circuit logic window below the editor. This window is updated any time a change is made to the equation. The NOT operand will be red in color in the shape of a circle and the center is open. If a logical NOT is used, it will negate the selected port in the equation. This reverses the logic for this port, hence the port must be in an off state for this operand to evaluate as true, and vice versa. The schematic shown represents the multiplex expression and circuit logic. The circuit logic is an aid to understanding and troubleshooting multiplex logic. The logic for the multiplex equation created in the multiplex editor is written out in text form, in the circuit logic window below the editor. This window is updated any time a change is made to the equation. The CAN monitor is used to watch data traffic on the CAN bus and determine the version number and state of all devices configured on the network. Of these two features, retrieving the version and state information can be performed by any user and may be useful to find offline modules or check the version of hardware, whereas the traffic monitoring features are generally only used by the manufacturer to resolve very difficult problems. Checking the state and version number of all configured modules is as simple as clicking the Check All button. This will cause the device selection window to update with version numbers for each module or an indication that the module is offline if no version was retrievable. Monitoring traffic on the CAN bus is generally used only to solve low-level problems that other diagnostic tools fail to find. Because the data is in such a raw format, this tool is most frequently used by a person having some background in reading J1939 messages. A brief overview of the controls is provided below. Device status, monitor status messages sent to the selected device from the System Manager. Messages to System Manager, messages sent from the selected device to the System Manager. Messages from System Manager, messages received by the selected device from the System Manager. Freeze, when checked this control stops monitoring and displaying bus traffic, when unchecked monitoring resumes with the current settings. The real-time monitoring is enabled by clicking on the Real-Time Network Monitor icon. When enabled, you can view the current state of the input or output. The selected input or output can be forced on, off or flash by clicking on the appropriate icon on the menu bar. The real-time monitoring is enabled by clicking on the Real-Time Network Monitor icon. When enabled, you can view the current state of the input or output. The selected input or output can be forced on, off, or flash by clicking on the appropriate icon on the menu bar. The selected input or output that's been forced can be released by clicking on the same icon that was used to force the state. Also, the forced selection can be reset by powering off the system. The lower circuit logic window is an aid to understanding and troubleshooting multiplex logic. The logic for the multiplex equation created in the multiplex editor is written out in text form. Here are the 6 steps. Step 1. Understand the vehicle. Step 2. Verify communications. Step 3. Check input and output status. Step 4. Check for faults. Step 5. Divide the vehicle. Step 6. Ask for help. This is not a document that always needs to be followed step by step. If you have a vehicle with no communication, there's no need to check inputs and outputs, but you would go right to step 2. Step 1. Understand the vehicle. The key to fixing any vehicle problem is understanding how it is supposed to work. Schematic diagrams are helpful when they are available. The I/O and relationship reports are spreadsheets that are generated by Vehicle Builder. They include information about wire designators, input and output locations, input commands, output logic, and load shed information. Knowing that an output could be load shed due to low voltage may be key to solving some problems. There may be a report of lights turning off, but when the truck is brought into the shop, they work. It could be that node voltage was low, indicating an alternator or battery problem, instead of an actual output failure. Contact the Vehicle Builder to get I/O and relationship reports, schematics, or any other information that will help resolve the problems. The builder knows how the nodes are programmed, and where components are located. Here is an example of module ports in a network report. You can generate numerous types of reports. Logged events, logged faults, system report, designer report, snapshot report, project data and project by module. System reports contain a list of every port in the system and its associated configuration parameters. To generate a system report, select System Report from the Reports menu on the main screen. The report columns are as follows. Port contains the name of the port. Device contains the device on which the port is configured. Address contains the address of the port using the format, first the device address then the port number. Log indicates whether the port state changes will be logged. Display indicates whether the port state changes will be displayed. Load management contains the load management parameters as well as the default state settings for the port. Interlock indicates any vocation interlock requirements that may have been configured in the multiplex editor. Multiplex equation displays the textual representation of the multiplex equation for the port. Project data is a list of every port in the system and its associated configuration parameters. To generate a system report, select Project by Module Excel Export from the Reports menu on the main screen. The enhanced feature would need to be enabled to auto-fill the connector and position for each node in the project. This is enabled in the System menu, select Options and then click the checkbox to use the enhanced device information. The report columns are as follows. Device port name contains the port name. Device name contains the device name. Address contains the address of the device. Output or input indicates whether the port is an output or input. Parent device indicates the device type for the port evaluated. Pin contains the pin position of the output or input. Wire ID indicates the wire ID of the circuit used for the output or input. Wire color indicates the wire color of the circuit used for the output or input. Wire size indicates the wire size of the circuit used for the output or input. Polarity indicates the polarity of the output or input. Protected current indicates the protected current for the output or input. Load management contains the load management parameters as well as the default state settings for the port. Module connector tab indicates the connector and name of the node or description. Step 2. Verify communication. Checking the state and version number of all configured modules is as simple as clicking the Check All button. This will cause the device selection window to update with version numbers for each module, or an indication that the module is offline if no version was retrievable. Step 3. Check inputs. Toggle the input switch and look for the real-time state change in the S-Key Pro software on the Network Editor or Device Editor section. If an Information Center display or an Ultra View display is available, you can view the input state in the Diagnostics section. Check for proper signal to the input pin. See the network report to determine if it's a ground or battery plus signal. Common problems include faulty switches, faulty wiring, bad connections, or possibly a bad diode, if it is an older trucks. Builders would sometimes put a diode in line with the switch, to make it ground only or battery only. Generally, an input diode failure would be a broken lead, not a burned out diode. Step 3. Check outputs. Force on the output with the S-Key Pro software, the Information Center display or removing the output connector from the module and applying 12 volts to the wire going to the device that is not working. If applying 12 volts, use a source protected with a fuse or breaker, in case there is a short circuit. If the device turns on, you know the device and wiring is good. Further investigation is required to determine why the node is not supplying the voltage. Use a voltmeter to check output voltage. When the output is on, it should be at or near battery source voltage. An output that is off with no load attached, may have a floating voltage of up to 9 volts. This floating voltage is caused by the internal fault detection circuitry. It can cause small LED lights to glow dimly. Common problems are bad device ground, blown light bulb, bad connection, or load shedding due to low voltage. The output might also be off for a diagnostics fault. If output current exceeds its designated current rating, the output will automatically turn off. The module will attempt to connect the output to the load 2 more times at 5 seconds intervals. If the output is still overloaded, then it will remain off. Step 4. Logged faults. Fault reports contain a list of system failures generally focusing on the devices going on or offline. To enter the fault report window, select Logged Faults from the Reports menu. If available, you can view the faults using an Information Center display. The S-Key system will record each fault occurrence. It will record the timestamp, device name and fault description. The data logger maintains a circular queue of faults that will overwrite the oldest faults once the end of the available space is reached. The fault queue can also be erased. See the section on resetting buffers under using the data logger tests. Step 5. Divide the network. If communication is lost, divide the network to identify which part of the network is causing the problem. If you remove a stub of the network and communication returns to the rest of the modules, then you know the problem lies with that branch, and you can troubleshoot accordingly. Common communication problems are water intrusion in the Y-splitters, shorted or open communication wires, and pins not properly locked into connector housings. It would be unusual to find backwards wiring on trucks that are complete. These are issues that would be found and fixed at the factory. Check ground wires to all modules. A module with a bad or missing ground can appear to be operating correctly but can cause inconsistent communication throughout the network. Step 6. Ask for help. The OEM that built the vehicle is your primary resource for how that vehicle was designed and manufactured. The OEM should be your first phone call if something on the vehicle is not working, and you don't understand why. The S-Key hardware and software are designed and manufactured by Class 1 Electronics. If you have software or hardware questions, or there are truck issues that are not getting resolved, please contact the Customer Care Center. We want to help find solutions. The Project Upload executable feature allows the OEM create an executable file that can be sent to the customer for loading a database into the Universal System Manager or SuperNode without having the S-Key Pro software. This is used when there's no access to the internet or connection concerns. S-Key Live is a remote connection within S-Key Pro software using the internet. A service provider computer with a full version of S-Key Pro software installed must be connected to the internet. The person requesting the service must have the read-only version of S-Key Pro software installed on their computer, be connected to the internet, and connected to the S-Key system. Located at the top right of the menu bar you'll find the Sign In button. Click on the Sign On button to start remote connection. The service provider will select the Provide Support to a Remote Vehicle, and the service person will select the Request a Support Session for My Vehicle. An access code will be generated for the service person. The service person will provide the access code to the service provider to enter in the box provided for the access code. The service provider will click on the Connect button to complete the final connection process. Now the service provider can upload, download the database and diagnose the S-Key system. The Project Upload executable is only available with firmware versions for the Universal System Manager 2.0 or higher and the SuperNode 9.05 or higher. You can access the read-only S-Key Pro software at www.firmware.class1.com website. This concludes Part 2 of S-Key Service and Troubleshooting Guide. For more information, please consult the S-Key documentation or contact customer care at 800-533-3569.